Right guys, this is going to be a brief tutorial on how to use plant simulation software, also known as Technomatics by Siemens. At the end of this tutorial, you should be able to create your own manufacturing system. So let's go ahead. The first thing to do is to install plant simulation software. Siemens offers a 30-day trial, so make sure to use your 30 days in a conscious way, because you're not going to be able to get another 30-day trial. So if you're in a team, if you want to test it first, well, use one license, and after that use the other license from your classmate. This is the link to download the plant simulation. So you only need to register. Here you select Mexico or your country, your first name, your last name. Tec de Monterrey is the company name, and your email, your phone, and then you get the trial for using plant simulation, right? After your download, you will open the this is the main window in plant simulation. First thing to do, if you are in the school, you go to preferences, and here in license you have to select educational. Most of the time it is on professional or in another one. So you select educational, you click OK, and then you close it. You relaunch the application, and now you should have here in license educational. You have to close it and then open or relaunch the application again. Then you create a new model. And here you're gonna select 2D. If you want to work in 3D, then it is a difficult task to turn it into a 2D, but if you start working in 2D, it's easier to get into the 3D view. So my recommendation is to start with 2D, and then you can click here, and you get the 3D model. But if you start working on 3D, you won't have that option. Well, my advice is to start working here in models, and then you create a new folder, and you call it I don't know, my project or something. And here you insert a new frame. What is a frame? Well, actually a frame is where you are going to work and where you're going to add all your models to maintain in order. I recommend to use a zip folder with a project on it. You can rename everything here with F2, so just click F2 and then you can rename everything. Well, the basic tutorial, or what you must know, is that we have MUs or mobile units, which are parts, container, and transporters. All right. And here in the frame, we always have an event controller. The event controller is what makes this a discrete event simulation, and that way events occur depending on the stochastic models, but also depends on time. So this is very important to notice here in this type of simulation. Right now, we start working with sources, and we have stations. So the basic simulation is as this. You need a source, you need a station, you process your unit or your mobile unit, and then you get a train. As default, source supplies parts, and if you run the model, now it is working. Now you can see it working. It supplies, it works, and then it drains. So this is the basic simulation, and now you have time to start working with the stations, the parallel stations, the assembly station, dismantle station, and all the other objects that are here in the toolbox. We're gonna work with material flow mostly. So here in the toolbox, this is called the toolbox. We have material flow, we have fluids, resources, information flow, user interface, mobile units, user objects, and finally tools. For the end of this tutorial, we only work with material flow, and all your project must be done using the objects here. And we're going to use also a transfer station, but later in the tutorial I will talk about it. Well, now it's time to practice. So now that you know the basics, you will have time to click on all of these subjects, and I will present a brief exercise for the simulation of a table producer. All right. All right. Now that you know the basics, let's proceed with a table producer exercise. I'm going to share the link with you. So first, here we're gonna have, or the advice is to generate your BSM, also for your project, generate your BSM, and now that you have your BSM, we're gonna start working with the creating a simulation. So here we have explicit information for suppliers. So we're gonna use different suppliers here. And as I said, you can rename this using F2. And here we're gonna have the goods supplier. We're gonna have the leg supplier. We're gonna have the box supplier. And finally, a truck supplier. So these suppliers must deliver parts here, and here it is going to deliver a container. A container contains parts, and transporter can contain other transporters or containers or parts. So you must think on how it is going to be assembled. If you want to pack everything into a box, then well, the box is going to be a container, which is going to contain all different parts from before. So here you must duplicate your parts, and the part is going to be named good. Another part is must be duplicated, and it's going to be leg. Then a container for box, and finally a transporter for trucks. Right. So as I said, here the MUs is the divided part of the simulation, and that's why you must duplicate. If you use this part and you compare with this part, it is mostly the same. However, if you change, you can change here the colors, you can change how it's gonna look like. If you apply this, then good is gonna be completely different to part. Well, objects inherit the father's properties. So our advice once again is to duplicate your MUs and bring them to your model. So you must hold shift, and then you can drag your components here. It is just to maintain order in the simulation. Now that you have your suppliers, it is important to highlight the main activities. The main activities, cutting, milling, assembly, packing, and finally shipping. All right, so As you can see, it is a very poor simulation. You can connect everything here and then you just connect with a drain and then you got a similar simulation to the one I presented to you. So uh, another way to do this, or the simplest way to do this, is just to connect everything and then you get a simulation. But this is not the end of this tutorial, so you're gonna do everything as it is intended. And as I said, you're gonna use this for your final project, so make sure to learn that you need order. And if you want to order these activities, you're gonna need frames. So basically, if you start reading the description of activities, uh, you have the cut to size operation, and then you have the milling station. And the milling station consists of two lines, whilst the cutting station just requires one machine. So let's say that you're gonna have here the milling station, but you can use an station or an operation for the cutting activity. So you can rename it cutting, and this is connected to good. At the end, we're gonna connect everything. Uh, it is also a good advice from simulators that you have everything isolated and then you connect everything. That way, you're gonna have order in your simulation. All right, then if we continue reading, we're gonna need a painting station. Then we're gonna need uh, a packing station, and finally a shipping station. And you can connect this directly well into the frame. We're gonna have this screen, so you can connect here the drain part of the simulation in order to count all the things that are exiting the simulation, right? So let's continue reading the description of activities. Well, I split the assembly station and the packing station. It could be seen as just one station, but for the end of this tutorial, I'm going to split them to see different activities inside each station. In that way, we can see that these resemble different areas of a manufacturing system. So we have the cutting station, we have the milling station, the painting, the assembly, the packing, and finally the shipping. So the suppliers must deliver for different areas or have access to different areas, as in reality. You can rotate with Ctrl plus T. And here we're gonna have the legs where we assemble finally our table. And here we have the box. But I'm going to introduce the truck supplier into the shipping station. So I'm going to trim the truck supplier and I'm going to introduce it into the shipping station. You have Control X and Control V, or Control C and Control V. However, you don't have Control Z. So take care about it. Alright, so the cutting station, or well, all the stations have this list of properties where you can introduce the time, you can introduce a setup, you can introduce failures, and well, the controls exit is for an advanced tutorial. So we're gonna limit to time, setup, and failures. And we're gonna also work with the importer, which is gonna be for for the human or the workforce in the plant, but here in plant simulation it is still an ongoing work, the importer part, so this is just aesthetic. It doesn't change a lot the simulation, so it is just to make it look fancy. So as it says in the description of activities, we're in the cutting station and it requires 3 minutes. You can introduce the 3 and 2 dots, and that is 3 minutes. You can click OK, and then you enter and you have that 3 minutes. It is the format it follows. So if you introduce only 3, it will be counted as 3 seconds. So take care with this. With 3 and 2 dots, you have the 3 minutes for your cutting station. Then, in the milling machine or the milling station, we have 2 different machines. One that works well and another one that doesn't work, or one that is older. So this is going to be the milling machine 1, the milling machine 1, and this is going to be the milling machine 2. Alright, so to connect the lines here, as we can see in the main, well, this is my main frame, we have the cutting and it is going to be connected with the milling station. So in the milling station, we need this type of connection. It is called interface. If we don't connect, it remains blue shaped but unfilled until it is connected. If you start connecting everything and these are not connected with the one in the main, then it is going to be marked in red that way. So this is another way to corroborate that all your connections are right. And this is for the entry. You can here click and change for entry to milling. Sorry. And you need an exit and exit from milling. In the names, you can introduce this symbol, the hyphen or the medium hyphen, but you cannot enter spaces. So you can use this type of name, and this is just to remind you about it. Well, as it says in the description, to the milling stations, first we need a buffer for everyone, and then we need a pick and place. So these are the pick and place. A common failure in the simulation or during the simulation is that the pick and place are too straightforward. So as you can see here, you can connect the buffer with the pick and place and then the pick and place with the milling. However, this is a common failure, a common error marked in during the simulation, that these are too straight. So if you got that problem, just erase the pick and place and add a different one with certain angle, so you can see that this is not the failure that I mentioned. Alright, so continuing with our activities, it says here that then we have another pick and place, so we're gonna enter a certain angle for this, so we won't have the problem mentioned before, and then it is transferred to a buffer, right? So this is going to be symmetrical for both stations. We can use only a pick and place for these two machines, so you can connect here this, and it's just to split the lines. It is not well described or undescribed with all the precision for you to think in different solutions for this problem. So be creative about it. Well, all right, at the end we're going to connect and add the different values that it mentions here, like this, the mean time to repair and the processing time and the capacity also for the buffers. So a quick way to return is just clicking Ctrl plus L, and then we're going to be here in the main frame. Then we get into the painting station. So the painting station requires an station and then a conveyor, a conveyor for drying cycle. All right, so this is the converter and this is the conveyor. Take care with that object, which is commonly mistaken by students. All right, so we're gonna have our interface, our entry painting, and we need our exit from painting. Afterwards, you need the approve or rejection part. So for that purpose, we're going to enter a pick in place, and it will send to the exit painting, which is continue here in the assembly station. But we also need one drain to say that this is scrap. So sometimes the pick and place is going to send here material and sometimes over here. All right. Now we continue with our assembly station. In the assembly station, it says that we need a leg supplier. So the leg supplier is going to send the legs over here. So it's entry legs, and then we need our entry for the station, which is going to be entry assembly, and we need our exit. So these are the basic components that you always need here. Exit assembly. In that way we can connect everything. If not, well, then you're gonna find in a trouble working with the things that you must connect. All right. Then it says that we need two assembly stations. Oh well, this is a part of the station. This is assembly station, right? So watch out. We need a conveyor. The conveyor is going to be needed for the legs, and then we must assemble with the goods here in the assembly station, and afterwards well then we need just to send them across here, the exit assembly. And then in the packing station we need the entry for the boxes. It's gonna be the entry box, the entry packing, and the exit packing. So it says that here we have a buffer, and then we're gonna have assembly stations. So that we have two different assembly stations here, and we're gonna need the boxes and the tables. Alright, so these are gonna be here, here, and then the box is going to connect with both of them. And now it says something about John and Michael. So here we have the resources, and we're gonna need the workplace for both of the workers. We're gonna need a worker pool here, and we're gonna connect this workplace with the worker pool and the other one. So as I just mentioned before, workers currently are just aesthetic. It modifies the simulation, however, it is not well, that important, or it is not studied in the software. We have different software to monitor the activities of the workers or to monitor ergonomics. So here in this software is just aesthetic, but it works, and you can add some relevant features such as the productivity of them. You can say that this worker is here than the other one, so that feature is interesting, and that's why we add the workers in this exercise. All right. So then we're gonna connect everything, and let's proceed with the shipping station. In the shipping station here we're gonna have the entrance for from packing, and here we're gonna have our train. So to activate the transfer station, you need to go to manage class libraries, and then in libraries we're gonna have here the transfer station. So you must apply and then click OK, and then in tools we're gonna locate the transfer station. All right, so this is gonna be the entry. Then we need a buffer, and directly from our buffer we can connect the transfer station to the truck. However, we need a track, which is gonna be from the truck to train station, and we can locate here, or we can see here how it's gonna be flowing our trucks, and we can transfer from the buffer to this track, or particularly to the trucks that are passing here, our boxes. So that's it, and now we're gonna return to this part to connect everything. Alright guys, so before going to connect everything, we have the vector graphics option here for the client to see what is going on with the simulation, and that they understand what's the simulation purpose. So we can add some rectangles or some objects for they to see better, for they to understand what is going on here. All right. So you can add text box also. And this is just aesthetic, I said. It is not a big deal here in the simulation, and it may seem not that important, but for the client, what they require. All right, so let's say that we can turn this into So we can add like this publicity for our simulation, and they can understand and see well, that at least we have a table producer here, and maybe that is important for them. So consider what the client wants also. Right, so let's proceed. Uh, we can connect the good with the cutting, and then the cutting with the middle station, right? So we will see the two different interfaces. These are called interfaces, the little triangles. So if we are entering the milling, then we connect this to the entry milling. And if we come here, now it seems blue, and it is filled in the exit milling. So to connect multiple times the connector, we need to click and hold Control, and we don't need to modify it every time or to click again, so you can continue adding connectors. All right. Now it seems red because it is connected in this side, but in the other side it is disconnected. So then we enter the painting station, or we can connect here to the painting station, and we connect to the entry. And we start connecting everything, right? So make sure that you really click in the object. If you don't connect in the object, it may seem that it is connected, but it's not, as in this example. We connect this, we think that it is connected here in the conveyor. It is not. It remains over there. So really click over the object, right? So here we can connect to the entry legs, and we can connect to the entry assembly station. The inside of the station. Right, so we need the entry packing. And here we connect to the entry box. And finally, from the bottom station to the shipping station, right? So here I'm gonna flow the legs, and here the goods or the tables that are coming. And here we're gonna have both lines coming from the conveyor. So it is important also the order of connecting the things. If you observe, I connect the first line from the buffer, from buffer to exit, and the second line from the entry box to the station, and then exit back. We can see the predecessors and the successors of every line, and it is important, especially in the assembly stations, because it says here for this station we're going to have the buffer as our main entry, and then as a secondary entry we have the box, and here we have the entry box as the primary entry. It is observed in this little number here. The one which is closer to the station is the one are the predecessors of this object, and then the ones exiting the station are the successors. So let's say that for the entry box, we connect first this line and then this line. It says here that it is the second successor of this entry, and it is important here in the assembly stations because we're gonna need in the attributes, we're gonna connect, or we're gonna say that we need the we're gonna have an assembly table, and here we need our predecessor and the number of parts that we're gonna need for them, and also which is coming, which is the main MU, and where is it coming from. It is coming from the first or from the second line. And here we only have two lines, but in a complex manufacturing system, we have up to 20 or 30 different entries coming to a single assembly station. So make sure to identify which is your main predecessor in this case, or for the assembly station for the first one. Our main component is coming from the second line, and for our assembly station 1 or the second station, it is coming from the first line. So take care with that. Finally, the shipping station, we only need to connect the buffer, and as I said before, the transfer station understands where the part is coming from and where is it going to. So now it seems that everything is connected, and now we have to say that the wood is not a part, it is a container. And why is it a container? Well, because it is going to contain legs, so it's also a container component instead of a part, right? So we drag it over in our folder, and we can drag the good here, and now this supplier is going to supply good instead of MUs. As you can see here, the or parts, it is by default that all the suppliers supply parts, but you can change just by dragging. Here we can add legs, here we can add boxes, and over the shipping station we can add trucks. Also, sometimes it happens that you cannot drag or modify certain parts of the frame. If you enter here in the middle station and you click lock structure, then you cannot modify this frame. It is as simple as you unselect the lock structure. It happens randomly while doing simulations, so make sure that you here in general don't have this option selected. Alright, so now by default every single station is working with 1 minute, so you must start adding the times here. As it says in the cutting station, we require 3 minutes, so we modify to 3 minutes. In the milling station, if it does not specify what is the processing time, well, we must infer that is 1 minute, right? And here in the second milling station also we're gonna add 1 minute. The buffers are coming with capacity of 8, which is the standard, let's say. But if you modify here, this buffer, like the root buffer, and you say that that is gonna be 16 and capacity of 16, every single buffer will be modified, right? Every single buffer. And it happens with all the stations, so take care with that. Don't modify the ones that are here, well, the root materials. If you do it, then all your simulation is going to be affected by it. All right, so we're going to add the mean time to repair and the availability. And this requires going to the failure and add. The availability for the milling machine 1, which is the older one, is just 70%, and the mean time to repair is 15 minutes. All right. We can also use distributions. Here we have the distributions where we add the mean, which is this, then lower bounds and upper bounds. So we can also introduce stochastic distributions here in the software. All right, so this is going to be for the milling machine station 1, and then in the milling machine number 2, we are going to have that is available 98% of the time, and now the mean time to repair is just 5 minutes. All right. In the painting station, we require that this station, which is properly the painting, it requires a processing time of 3 minutes. And then we have the conveyor, which is going to be a 15-meter conveyor. Here we have the length of the conveyor, so we can add 2 meters. And then you can modify the speed in the conveyor. We can modify also the width, and it affects the time that the parts are going on. So we can say that the part is moving just 0.1 meters per second. That way the drying time is going to be 2 minutes and 30. And here we also have the part of the reaction. So let's say that the exit of the pick and place by default is cyclic, but we're going to say that it is going to be random, and for the different successors we're going to need, that is important why we need the successors here. You go here and click random, then it is going to say, well, from all the universe and from all the random over the time, which percentage is going to be on the successor number 1, which is going to be 95, and 5% is going to be sent to scrap. And this is random, but it is consistent over the time. So that's why we need to know the successors. If we invert this, or if we connect first the pick and place to the scrap and then to the exit painting, then we're going to have this reversed. So watch out. Well, over our assembly station, we're going to need also the predecessors and the successors. And we're going to have here the entry of the legs. So so these are gonna be 1 minute long, but we need well, it works 1 minute for both of them. But the most important thing here is that we need to define which is going to be the container and which is going to be the part. So for the first assembly station, we have the main part that is coming from previous stations as the main MU. It's coming from number 1. And then we need 4 legs from the second processor. Alright, so that is, and we can attach. And we're going to click on attach to see that here is really forming a table. You can also click on delete, and if you click on delete, we're going to have only the main part. If not, we can see the different components attaching each other. So that's why we click on attach instead of delete. And then we click over here, we have the 1 minute, and it is also coming from our first predecessor, the main mobile unit. And let's do the same. We need from the predecessor 2, which is the leg supplier. Here we can see, and we need 4 legs to form a table. And that's it over here. And over the packing station, we can define in this section, our box is going to be the main component, which is going to contain the table. So for the first assembly station, our main component is not the number 1, is the number 2, and we need 1 table coming from our predecessor number 1 to attach a box with a table on it. And here we can click on the delete MU, and the main MU is going to exit. The main MU, which is the number 2, is going to be just a box. Alright, and over here our main component is coming from the processor number 1. We're going to delete, and we're going to have the main MU, and we need 1 table coming from our predecessor number 2. And it's a common habit that you click first apply, then OK. Why that habit? Because here in the assembly station, for example, or in the painting station, you can modify the exit. Let's say that you want cyclic, but you have this list. So until you click apply, it's going to disappear. Also, for if you click the percentage or the random that we have here, until you click apply, then you can see the different options that this object supports. Well, now working with workers, you need to drag first the worker, and now it is working in this assembly station, and you can bring your worker close to your station. This is just a step just to see that it is working here. Then you need to modify the worker pool. And the last step when working with workers is that you need a broker. So the broker is going to send the instructions to the worker pool, and then the worker pool is going to receive orders from the assembly station. So it works, it flows in this way. It remains instructions from the broker, and then the broker sends one worker. So then you need to drag your broker into the worker pool, and now you can see that we have here the broker. If you have multiples worker pools or different worker pools that are working in different areas, you must drag your broker into that worker pool, right? So in the worker pool, by default, we have one resource, and you cannot modify it. You have to close and then click over here. This enables this option as in here, and if we don't have that part, then we click apply and OK. It is really not receiving anything, so you need to enable the option of the broker. So when you enable the creation table, you can add another resource here, because this is going to be named after John, and well, John in the other way, and this is going to be named Michael. So you click apply and then OK, then we're going to have the add workers. It says here that John is slower than Michael by 100%. Well, let's say that it's just 50%. So Michael is gonna work 100 at the efficiency of 100%, and my John is gonna work just the 50% of the time. We can also modify the speed, and we can modify the shifts of the calendar, and this is gonna be explained in this tutorial because it is the basic. And if you can add shifts or calendar shifts, but it becomes a really complex simulation. Then you have to mark that the travel mode is using footpaths. If not, the workers beam to the workplace or move freely across the machines and across everything. So make sure that you mark walk along footpaths. And the workers get job orders in the pool only. If not, they can be randomly modified by methods or by machines that require of them. So make sure that they get job orders in the pool only. So after modifying the worker pool and dragging our worker into the assembly station, then we can modify the importer. So you need to drag the broker here. You have to enable the broker, and then you have to click that it is active and that you require services. And here we have that in the first line John is gonna work. So here is where we specify the name of our worker. Right, okay. And we do the same in the next assembly station. We drag the broker, we enable the broker, and then we activate the services. And the alternative here is Michael. So after that, in the shipping station, we come here to our transfer station, and we're gonna indicate where the parts are coming from. And we click buffer, and then we want to to transfer them into the track, not in the truck. Uh, it is going to be over the track. So the track, here we can see a sensor position. We can modify it to 5, for example, and then we can see that the sensor is moved over here, or we can modify it to position number 1, and our target is the track, not the truck, the track. And here in advanced attributes, we specify that the target or container is always stopped at this position. So if we start the simulation, we can see that the truck is moving until reaching the sensor position. If we don't activate that option, the truck is moving freely. So it is not going to stop over there, and it is going to continue. So we need the trucks to stop when they reach the sensor position. That's why you must tick this option here. And now you have your simulation. So let's say that you want to simulate 8 minutes, and that's why it is important to have an event controller here. That you want 8 hours or a shift, and you can modify the date and you can modify the starting hour. So if you just enter the 8 hour, well, then it is going to be displayed over here that we have this everything is 0, but when you start the simulation, now you can see a progress bar and the time is moving. Well, now it's 1 second, 2 seconds, 3 seconds, and you can see the advance of your simulation. So I recommend to enter a shift, and these are other options enabled by default that delete the M use or reset. If you don't do that, well, then your machines are going to start with some mobile units, and you can have a trouble finding what is the error of the simulation. And you have step over animation events, and that's when you start running, you can see these little dots over here and over here, and basically in each moving part on each working station, you can see that it is waiting here. The yellow one is that it is stop because there is a block ahead, and the green is that it is working. And at the end we can see also a summary report. So let's say that we want our simulation at full speed, and we have marked this summary report, and then we're gonna see this is the summary report. Alright, so it finished the simulation, it is on 8 hours, and this is our report. In the painting station we have this scrap, and because we haven't indicated what we want to achieve with the report, it just locates the training stations, and it just shows what is convenient here in the summary report. But every time that we run a simulation, we're gonna have that summary report, and that can be troubling for some some of the clients or for the simulators, because we don't want to see every time a simulation finishes our report, so we can add our own HTML report here. So when the simulation finishes, we can see the report. We can change over here that we are not John Doe. So we can see a complete report here with the simulation frame or the main frame and the statistics, the box, the cutting, the life and the good, the different drain statistics, and here we have the signature of the report. Let's say, and you can export this to a PDF or an HTML report. So it's a better option to have the HTML report rather than the summary report shown here. The summary report is useful when developing, but it is more comfortable to have the HTML report, and you can check this report every time you want. You finish a simulation and you want to share with your colleagues, then you have the option here. But the simulation or this frame is not important unless you have the information that it requires over here. And it says that you must produce your tables and you must do your simulation here, but it asks how many tables are you able to produce per shift and determine the number of trucks you are using and number of badly painted tables. So to do this, we need to add more information to the simulation, but we have already everything connected, so it's easier to follow. So to collect that information, we must use the display option here. You must set this as active, and we're gonna collect the information coming from the let's say that we want to collect the information in the packing station. So every time that a box exits this packing station, is gonna enter here, and we can collect the information at the entrance of this buffer. All right. So let's say that we start here, and this is in the shipping station, and then in the buffer, and we can collect the stat num in. What is stat num in? Statistics of a number in the entrance of the object. That's why stat num in means. And we can say here tables produced. These are the properly the packed tables, and we can modify as this is the most important information. We can put it in large, and we can put it with a different color, let's say blue, and in the main frame we're gonna have the tables produced, and the information is coming from the shipping station at the entrance of the buffer. We can also collect the information about the trucks we are using, and that information is coming from the shipping station and in the train. And when they enter the train, well, that's the number of trucks we are using for our simulation. So trucks needed. And it is going to collect the information about the trucks in this little display here, and the number of badly painted tables. And the badly painted tables information is here in the painting station and at the entrance of scrap. So why we use the stat number instead of another variable? It is the easiest one. When we start running a simulation, we can observe these statistics here. And they update in real time, but they are not showing that way. That this is working 100% of the time, that the content is 1, that the minimum content is 0, and the entries. And this is the number we're searching for, the number of entries here. So over the time we're going to have different entries. We can adjust the number of now we have 5 entries here and we have 4 exits here. One is being processed currently. Well, we were missing some specifications here, such as the load bay, for example. We can add here a 441, and then the capacity of the truck is 16. Also, over the packing station, I forgot to mention that you must untick this option, get job orders in the pool only. If you have this option selected, then the worker is going to come here, stop working, and then it is going to stop doing everything. So untick this option here for the worker to continue working here and here also. If not, then the worker is going to return and then come back and then return. So make sure to untick that option over there, and that's it. You have your simulation. You can modify here the time, and over 1 hour and a half we have 23 tables produced, and we have used 1 truck. This is a general solution for this exercise of 146, and with 8 badly painted tables, and you need at least 9 trucks. This is a general solution. You can distribute your stations in the way you prefer, and you can suggest some changes over the assembly stations, for example. And I mentioned before here in the assembly station, let's say for this, in the box, as you're deleting here the MU, then we're going to have just a single box. But here, if we attach the MUs, then we can see a table and then the little legs pointing in different directions. So that's just visual. If you want to change this in in a 3D environment, you can do it. Let's say that you want the milling here, and you can see the quick and places and the robots and all the machines, and you can modify here the machines, but this is just aesthetic, I mentioned before. And that's why, well, that's the simulation, and with this simulation you can estimate the number of tables produced and your trucks and your badly painted tables, but you can add different information. Let's say that you want to add a chart here, and that you want to see the occupancy of the pick and place, and you can modify and change your to display it in the frame, and now in real time we can see the occupancy of the pick and place, let's say, or that you want to see which of these milling stations is better, so you can add both milling stations in the chart, and you can see the research statistic, and you can modify it to stay in the frame, display in frame, and the interval that you want to collect data is 1 minute. If you want a more specific case, let's say that you want a 30-second sample, you can do it, and you want a bigger graph, then you can do it also. 22, and then in real time you have that type of information over here. And apparently the milling number 1 is failing more than the milling number 2. So if you want to compare also machinery or to compare different models, well, you can obtain their mean time to repair or the information sheet of the provider or the supplier, and you can address that information in your simulation to corroborate that is going to work in your manufacturing system or not. Also, you need your BSM to add all the times. Let's say that the 3 minutes and that you have defined that you need 4 minutes here. Well, you can modify to 4 minutes, and let's see the impact in the tables produced. We had 146, and now we have 111. So if you want to modify, or you have your BSM as estimator, but you can modify your parameters over the simulation to corroborate that data. You want to see the report? Well, you can see the report here. The report only shows what is available here. So if you want a report here, you can add your HTML here. You can run your simulation, and then the HTML report will show this frame information: the buffer, the portion of the working time, which is the green, and the portion of the failure. So you can add really a lot of information in your reports or in your simulations here. If you want to add everything in this single frame, it is possible, but using these parameters of displaying properties, let's say, but all the things that you have here in frames is going to be over a post here, and so you will have a mess of information. So my advice is to, if you need to collect information from this frame, well, then just add your report here, and you can show your report here, and you can collect information here. So in that way you have the information split by areas of the manufacturing system. So that's the basic tutorial. If you are interested on collaborating with us in the part of making simulations for different purposes, well, you can contact Dr. Arturo Molina or me.